everybody back with Advent of Code 2015, day 6. Probably a fire hazard, because your neighbors keep defeating you in the holiday house decorating contest year after year. You've decided to deploy 1 million lights in a 1,000 times 1,000 grid. Furthermore, because you've been especially nice this year, Santa has mailed you instructions on how to display the ideal lighting configuration. Lights in your grid are numbered from 0 to 999 in each direction, and the lights at each corner are at 00, 099, 99, 9999, and 9990. And the instructions include whether to turn on, turn off, or toggle various inclusive ranges given as coordinate pairs. Each coordinate pair represents opposite corners of a rectangle inclusive a coordinate pair like 00 through 22. Therefore refers to 9 lights in a 3x3 grid. So it's inclusive. The lights all start turned off at the beginning. To defeat your neighbors this year, all you have to do is set up your lights by doing the instructions Santa sent you in order. For example, turn on 00 through 9999 would turn on or leave on every light. So leave on if they were turned on previously. Toggle would toggle them. Turn off the ones that were on, turning on the ones that were off. And turning off just turns them off. Okay, how many lights are lit at the end? And then our puzzle input is all of these instructions. You don't really have, okay, let's just do this example here. What we need is some kind of grid. Which is a mutable list of mutable list of hints. So we just have those. We can also generate it differently. We can go for each. We go through the grid just to see how it works as well. 0 to 999 for each y. For each x and y, we can go in the grid and see if we can actually turn it on or something. So at the beginning our list is empty, so we can't really mutate it like that, I think we should add a list into the grid at each position. Or we can just add it actually. Add. Oops. Something like this. So we take this generator from 0 to 999 and map it so we have a list, and then we have a mutable list and we map it again. Not super efficient, but then we have a grid. Actually, we don't want to map it, we just want to map zeros maybe for off, and 1 can be on. Grid, and see how it looks. Yes, we have loads of zeros, which is probably what we want. Grid 0.size 1000 element in one of those lines. And I forgot to delete this rest here. So now we know how to fill a grid with zeros. Then we want to basically check the instructions. So we had 3 options: turn on, off, and toggle. So what we can do is for each line in our instruction, we can split it, and then we can say instruction is this maybe, and then when instruction 0 is turn. Actually, curious, I just toggle. Okay, if it's toggle, it's easy. We do something. If it's turn, we have to go and look at instruction 1. If that's on, we do something. If that's off, do something similar. Let's just do 1 first. Let's do on, because we have that here. We need to fix this. We need to apply this. So we need to parse these 2 coordinates, and which is instruction 2, 3, 4. Some incident 2 and 4. 2. And then I can split that comma, and we can maybe destructure it to, I will just take the first part and the second part. Make them ints, and we have the indices. This kind of start x, start y, and then we get b, which is instruction 4. Let's split, comma, and x to int, and y to int. So we just take this instruction 4, for example, this one, split it with comma, so we have 2, a and b, or and x and y. Start x, start y, and x and y. And then we can just go through that, start x to start y to end x, sorry. And start y to end y for each x, for each y. Okay, obviously we should take b here. And we can call it start, maybe. Start. And cool. Then we have an x and a y, and we just need to update our grid. Equals 1. And then we can count I can just flatten it and then just count the number of ones, should have a million now, because we just turned everything to a 1. Nice, perfect. Then let's try toggle. Toggle 0 through 9990. Basically, we do the same. Just this is the first, this is the third pair of numbers we need to parse, so we can just copy this on everything. Change this to a 1 and this to a 3. And we go through start and end coordinates. What do? We have a 1, turn it to 0, else, turn it to 1. That's the toggle step. Let's see what it does. Turn on 1000 lights. Yes, 1000. Cool. Then we go off is the same as this. So we could probably do it like this. We do the same thing as we did with turn on. We just say parse all the stuff, and then we know if we're turning things on or not here. And we can check that one. Turn off. Actually, this should just do nothing. Well, it should just reset everything to 0 and have 0 in the end. Okay. Let's run this with all our stuff and see how many lights are on. 400,410. Let's see if that's correct. Nice. Part 2. Well, let's check again. I think it's clear, right? We have toggle or turn. And then these ranges just go through the grid. We either toggle it, if it's on, we turn it off. If it's off, we turn it on. Or we turn it on regardless of the current state, or we turn it off regardless of the current state. So part 2 is you've just finished implementing your winning light pattern when you realize you mistranslated Santa's message from ancient Nordic Elvish. The light grid you bought actually has individual brightness colors. Each light can have a brightness of 0 or more. The lights all start at 0. The phrase turn on actually means you should increase the brightness by 1. Turn off means you should decrease the brightness to a minimum of 0. Toggle actually means that you should increase the brightness by 2. What is the total brightness of all lights combined after following Santa's instructions? So we just increase with turn on, we decrease with turn off, and toggling increases by 2. Okay. So on is easy because we always just increase. Off, we want to technically decrease, but to a minimum of 0. So we just say maximum of 0, because if this is 0, then I subtract 1, I have minus 1 here, and then I have 0 here, and the maximum will be 0, so I will lower bound it at 0. Toggling should I do? Increase by 2. So we just do the same as we do here. Just with 2. So unless I misunderstood something, this should actually be the answer. Let's see. No, I think I must have misunderstood something. Turn on would increase the total brightness by 1. Turn off actually means that you should decrease the brightness. I mean, we also have a suspiciously small number, so maybe we just instructions 300. There must be something wrong with the toggle because it's not increasing here. That's my thinking. Actually, I'm counting the ones and I'm increasing them higher to 1. So what I should do is sum anything in the grid. And then I should get a larger number. Yeah, 15 million makes way more sense than having a smaller number than part 1. Okay, that's correct. And we're done with day 6. So the problem in the end here was that I was counting the ones, and actually I should just be summing the grid because that will give me the sum over all the higher increase values in the grid, which is what we need in round 1. We only needed the ones, and now we need the sum. So thanks everyone, see you next time.